All right, so quadratic formula is 6.4. And I do have links in my presentation that are not currently working. So, but this is a quadratic formula. Y equals negative x plus or minus the square root of b squared minus 4ac all over 2a. And the a, b, c in question are from our standard form where we have y equals a x squared plus bx plus c. So those are our a's, our b's, and our c's from there. So remembering this formula and how it works is important to this lesson. So we're going to go to YouTube and try to remember this.
X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a.
All right, try to forget it now. So basically, this is a formula for finding our roots or finding our zeros or finding our x-intercepts. So it's one other way that we can find these things. So we can be factored. We've done a couple different ways of how we're going to find them. This is another formula for it. It has a proof, and it goes through it in the textbook. I'm not going to harp on it, but here's another video that shows how that works.
If you try to solve a quadratic equation, I promise you it's possible without any frustration. If you take everything, move it to one side, stop by x squared, x and the rest. Alright, now take the coefficients, name them a, b and c, and if you know the right formula, you will see that you get the solution in the very next step. Just sing the song in your head. Negative b plus or minus the square root of b squared minus 4ac over 2a. Negative b plus or minus the square root of b squared minus 4ac over 2a. Okay, let's start with our equation, and our job is gonna be solving this now for x. So let's take minus c, multiply by 4a, and if you now add b squared, it all looks way too complicated, but don't be scared. Just take a close look to the left side and you see there's a binomial formula with 2ax and b. So altogether this is the square of 2ax plus b, and now we have only one x. So the next step will be to get rid of the square, and if the right side is not negative, the square root must be one solution. But there's an alternative, cause minus the square root yields the same if you square it. So we write plus minus, and now we are at the point where it only takes two more steps to solve it for x. And if you look to the left side, you know what will be next. Subtraction of b and division by 2a is giving us a formula for x. Okay.
All right, so I'm not expecting you to be able to figure out the quadratic formula's proof, but there it is. That's how it works. So basically, if we started with our, can I draw on here? No, I cannot. If we started with our ax squared plus bx plus c equals 0, and we try to solve for x, it gets a little bit complicated because we've got the x squared plus the x, but when we use our rule on the fourth one down, we've got basically a squared plus 2ab plus b squared, that formula. So we're able to then jump it into 2ax plus b all squared, and then it gets a little bit less complicated. So I'm not expecting you to be able to do that, but I am required to show you the proof and show you that this was not just pulled out of thin air, that it actually comes from how to solve for x in that formula, or coming from the original equation. But I just like remembering x equals negative b plus or minus the square root of b squared minus 4ac all over 2a is important for quadratics. So memorize the song.
And it's negative b plus or minus the square root of b squared minus 4ac over 2a. Negative b plus or minus the square root of b squared minus 4ac over 2a. Negative b plus or minus the square root of b squared minus 4ac over 2a. Negative b plus or minus the square root of b squared minus 4ac over 2a.
All right, get it stuck in your head. That's what it is. So another part that we need to start looking at is how many roots something has. And I did kind of show this a little bit in one video, but we've got 3 options, and actually kind of 6 options, but they end up being the same. We've got ones that we have no roots, or no real roots, sometimes they say, because it never hits the x-axis. So these ones only go off. So those two only are just above the x-axis or just below the x-axis. It never crosses. Then we have those two, which have one real root. So they only touch the x-axis once. The vertex is on the x-axis, so there's only one point of interception. So right here it would be 2. Both of those graphs, they can either be just above the x-axis or just below the x-axis, but they just touch it once. So right here we've got 2, 0 as being the vertex for both of those. So we only have one point where it touches the x-axis. Whereas these two, well, that was silly. Erase that one. I wanted to show one that opens down. These two examples have 2 real roots. So they each touch the x-axis twice. So that would be most common because a lot of them cross, or it doesn't have to be, but those are the ones we've been working with thus far that have 2 real roots. We want to find x equals 2 different things. So those are the 3 options, and the quadratic formula shows us very quickly which ones we're dealing with. So this is the quadratic formula again, the formula for determining the roots of a quadratic equation of the form ax squared plus bx plus c equals 0, when a does not equal 0, x equals, I'm not going to sing for you, negative b plus or minus the square root of b squared minus 4ac all over 2a. Cool things about this. We can find the x of the vertex. So our x coordinate of the vertex is x equals negative b over 2a. So again, our a and our b are what we're talking about up here. This is a new way. We were struggling with this a bit, how to find the x of the vertex, how to find, which is also the line of symmetry. So our line of symmetry, or our x coordinate of the vertex, is x equals negative b over 2a. Another cool thing, that's not really connected to the formula, but the other cool thing is this under here. So we went into this a little bit because I had given you an example that didn't work out. But this little guy, anything under, so we talked about square roots. And we can't have a negative something underneath a square root sign. That can't be done. Because anything squared is going to drop the negative. So negative 3 squared equals 9. 3 squared, equals 9. Therefore, the square root of 9 equals plus or minus 3. Both of those are possible answers to the square root of 9, which is why we have the plus or minus sign here. So this that's underneath the square root sign is important. Is b squared minus 4ac. It tells us what if we have one root, no roots, or 0 roots. No, that's not right. 1 root, 0 roots, or 2 roots. If it is less than 0, so if we get a negative in there, so if our negative b plus or minus the square root of, and we end up with a negative number in here, make it a y because we've already got an x. Then that means that we have no real roots. Our graph is going to look like this or like this, where it's not going to touch the x-axis at all because we can't solve that. So it has no real roots. Thank you, Facebook. When we have a 0 in there, we end up with 1 real root. So if, and we'll go through examples, if we got negative b plus or minus the square root of 0 all over 2a, then obviously all of that disappears and we just end up with our negative b over 2a. There's only one answer, which ends up being our line of symmetry, which ends up being our x to our vertex. Same as this. Then, if we have a positive number, or when b squared minus 4ac is greater than 0, then there are 2 real roots. So if we end up with a positive number under here, just a positive number, I'm just using y because I want a positive number. Then we're going to end up with 2 possibilities. We're going to end up with negative b plus square root of whatever that is, and we end up with negative b minus the square root of whatever that is all over 2a. So there's 2 possible answers. There's a positive square root of whatever it is, and there's a negative square root of whatever it is. We end up with 2 answers when we end up with that. So we end up with 0. Nobody's ever going to be able to follow this if you're just looking at my drawings. All right, so other things to remember. Note, remember when we take the sign, we need to take the sign with the number. So if this is our equation, 2x squared minus 3x minus 4, then our a is positive 2. Our b is negative 3. Our c is negative 4. So don't get confused by that. You should always write this out before you start so that you're not just pulling that 3 and that 4. You remember that that is negative 3, that is negative 4. So write that down. Stop, pause this, copy it out, put that note somewhere, because that will be the number one mistake that I see is people going to forget that. All right, let's go for it. Example 1, real roots. Use the quadratic formula to solve each equation. Where necessary, round to the nearest hundredth. A. So, remembering our formula. So first we write them out. These are all positive, so it's not so bad. A is 2, B is 9, C is 6. What do we want to do? We want to go x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Remember that formula. And then when you write it out, go back to the book. Make sure that you have written it out correctly, because writing out the formula incorrectly is the next way that you are going to mess up. Now, fill in our a's and our b's and our c's. So x equals b is 9 plus or minus the square root of so write it out. Don't try and mix them or put them together right away. Write them all out. Color coordinate your A, B, and C if you want to make sure that you are doing it right. Some people need the visual. You are a 2 and you are a 2, and C is only used once. C gets to be 6. Now you can start combining stuff a little bit easier. So I can drop my bracket here and make that a -9. Make sure I've got my plus or minus square root of. So I can do both sides of that minus sign kind of simultaneously. 9 squared is 81 minus 2 times 4 is 8 times 6 is 48 all over 4. Simplify what is within the square root sign. 81 minus 48 is 33 all over 4. So now I know, because I've got a 33 in there, that I'm going to have 2 real roots. So I have a positive number under my square root sign, so I know I'm going to have 2 real roots. So now I can't finish this from here. I need to split off into 2. So I know one of my roots is going to be -9 plus the square root of 33 all over 4. And one of them is going to be -9 minus the square root of 33 all over 4. Now, this is considered the exact roots. So if the question asks you for the exact roots, leave it in that formula, because 33 is not a perfect square. If it was 25, then yes, you could switch it to 5 and start making and finish the rest of it, and you would have an exact number. But because we're going to need to round when we take the square root of 33, it's not a perfect number. Then we need to it's not going to be an exact correct answer. So we need to be aware that this is the correct answer, but you are going to have to find the incorrect answer, or the not complete answer as well. So square root of 33. Calculator's not working. So all together, so then we end up with x equals -9 plus, and I'm going to round it to 2 decimal places, 5.7 0.74 all over 4. And x equals -9 minus 5.74 all over 4. And then we end up with x equaling -0.81. So we put this dot over top of the equal sign. That means approximate. You can also write it as x with squiggly equal signs. That also means approximately the right answer. So we have to remember that we aren't writing a correct answer when we finish these up. So the exact roots are those ones, they're most correct. But this is the how to graph it. We need kind of the close answer. So we put that dot on top of the equal sign to show that it's not 100% the right answer, but it's going to be close enough for our graphing purposes. So then it says verify using technology. So, what did I do for this one? This is verified using technology. So if you take your Desmos and plug in our regular thing, don't put equals 0 like it says in the textbook. That will give you a really weird answer, which will still have the same roots, but the graph will be completely weird. And then when you just touch the point of x-intercepts with in your device, it'll give you the x's. So that's our proof that we've got the correct one. Number 2, or B. So B, A equals +4, B equal, well, first we got to rearrange this. So first let's rearrange this formula so that we are equaling 0. So we always want it in the correct form. So let's rearrange first. Equaling 0. So then we can say A equals 4, B equals -12, and C equals 9. Then we write out our formula again, which is x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So c only gets in there once. 2 a's and 2 b's, if that helps you remember it. Then fill in our blanks. Remember that negative is kind of outside the brackets. Sometimes that might make a difference. Oops. So A is 4. 4 goes there, oops, and there. B is -12. So this makes a difference to put that negative on the outside. So I'm going to negative on the outside, negative on the inside, and our -12 in there. And then our, oops, I already used you. C is just 9, and we get that in once. So again, x equals, so a negative times a -12 is +12. Remember the plus or minus square root of -12 squared. We should know our squares. 144 minus 4 times 4 times 9 is again, for the magic of calculators, I don't know how to do that one in my head, but 12 squared we should know in your heads. All over, and obviously that was an easy one, 8. So now we end up with 12 plus or minus the square root of 0 all over x. So how many roots do we have? So we've got one real root. So we know right now that when we graph this, we have a positive a, so it's going to be shooting up, going to be opening upwards. And we know we have one real root, so it's going to end up on the x-axis facing up with just its tip touching wherever that it falls. It's going to look something like that. So I already know it's going to look something like that. I just need to figure out what that point is going to be. So 12 divided by 8. And we can break that down to 3 over 2, dividing each side or each bit by 4. So our lowest fraction is 3 seconds. So now I can put that in. So that's the same as 1.5. So if we put that 1, 2, so this is 3 over 2, 0. Let's try that in a little bit better. So that is my vertex. That is my line of symmetry and the x of my vertex when I only have one real root. So I already know what that's going to look like. I don't know exactly how wide or how narrow or what the graph is going to look like, but a basic sketch, I know it's going to be on 3 over 2 is going to be the x of the vertex. It's going to be just touching the x-intercept. So solutions from the textbook. Pause and look through that. For A, I've already talked about its graph. B, again, thinking about it, I can see that the trinomial on the left side of the equation, oh, something else to think about. When you look at this, it is a perfect square trinomial. So if you recognize that, you already know there's going to be one answer. So if we were factoring that, we know what we would end up with. 2x minus 3 squared. So we know we'd only have one answer for x that would be doubled, and that we could solve for that and get the same answer by factoring. So when we know we have a perfect square trinomial, we know we're doing a squared plus 2ab plus b squared equals a plus b all squared. Or in this case, sorry, this is minuses, which just changes those two. So perfect square trinomial, we could have just thrown in there. So when you see a perfect square trinomial, recognize that you know you only have one real root. The only ones that will have one real root will be perfect square trinomials. And again, that's verified using technology. Again, use y equals and not 0 equals in order to get the right answer. Just put it into Desmos to make sure that you have a correct graph. So this is, again, we've already talked about it, the x-coordinate of the vertex is x equals negative b divided by 2a. And this is the proof for that. So again, you can pause and read it over and figure it out. But when we find the vertex, when we have the two x's, so when we have two roots, we have two zeros, we have two x coordinates, the way to find the axis of symmetry before would be to find the one x plus the second x divided by 2 is going to equal the axis of symmetry. And this, people are still struggling with this a little bit. I think that's a bit my fault. We'll go through it again. But in order, so basically that's saying x1 plus x2 all divided by 2, and then they're calculating all of that and figuring out that that is indeed true. So you just have to know that the x-coordinate equals negative b divided by 2a. I don't expect you to be able to prove it at all, but this is how it works. Example 2. Example 2, use the quadratic formula to sketch the parabola. Find the x-intercept, the vertex, and the equation of the axis of symmetry of the quadratic relations y equals negative 5x squared plus 5x minus 3. So again, whenever we look at something new, think about what you know already. We know we've got a negative 5. Therefore, what does that tell us? It opens downwards. We also have a negative 3 as our c, so the y-intercept equals negative 3. So things like that, check them out. When you finish your graph, go back and look. Does it open down? Do I have a negative 3 as a y-intercept? Does this make sense? Use all the information that you have. So right now we want to find the x-intercepts. So the x-intercepts are our roots or our zeros, and we are going to use the quadratic formula, obviously. That's why we're learning it, to find this. Plus or minus the square root of 4, oops, let's not forget it already. Plus or minus the square root of b squared minus 4ac all over 2a. That's the part I always forget, is whether or not the 2 is a or the 2 is c. So now I'm trying to remember that c is only used once, so I've got 2 a's and 2 b's that I need to play with. So use mental tricks like that. So a equals negative 5. B equals 8. And the textbook suggests you color coding like this so that you remember where things go. So a is negative 5. We've got an a there and an a there. B is 8. And C is negative 3. Remember to bring those negatives along for the ride. They are so important, and it's going to completely mess up your answer. All right, 8 squared is 64. Now I've got minus 4, minus 5, minus 3. So 2 minuses cancel each other out, but we still got another minus, so we know we're going to end up with 3 minuses make a minus. So altogether, 4 times 5 is 20, times 3 is 60. And we've got more negatives on the bottom with negative 10. Negative 8 plus or minus the square root of 4 all over negative 10. So again, getting to this point, we know we have how many? 2 real roots, because we have a positive number under that square root sign. Therefore, we've got 2. And this one, we can just keep going. We don't need to show our exact roots and then show our real roots or our simulated roots, because we can find the square root of negative 4. So let's split it up right here. Square root of negative 4 is 2 all over negative 10. And then we also have x equals negative 8 minus 2 all over negative 10. So then we end up with negative 6 over negative 10, which we can simplify to two negatives, make a positive, and we end up dividing both by 2. We end up with 3 over 5. And we end up with negative 10 over negative 10. Again, if you have trouble, which again, the negatives cancel each other out, and 10 over 10 is just 1. If you have trouble with integers using minuses and minus, so minus 8, minus 2, some people still have trouble with that. Learn how to use your calculator correctly. I can't stress that enough. In this case, I like to keep them in fractions. You could also say x equals 0.6 to make it a little easier if you want to do that. So that is kind of our first part. Those are the x-intercepts. So therefore, let's use pen instead of eraser. Are 1 and 3 over 5. What's next? We find the x-intercepts of the vertex. So in order to find the vertex, give myself enough room, good. In order to find the vertex of the sketch, we use this formula. X equals negative b divided by 2a. So we get a, b, c. So x equals negative b. B is 8 over 2 times a, which is negative 5. So we end up with negative 8 divided by negative 10. We end up with 4/5 positive because those two cancel each other out. So it's not that far off. So now we need to solve for our y. So we put this back into our original equation, original way up here. Don't use so always use the very original equation whenever you're doing stuff like this. Don't use a factored form or anything to make sure you haven't made any mistakes. 4 divided by 5 squared plus 8 times 4 divided by 5 minus 3. So we end up with 16 over 20 plus, and so remember that when we're doing fractions, that 8 is over top of 1. We multiply the tops, we multiply the bottoms. So we end up with 32 over 5 minus 3. Now our textbook has moved us into fractions, or moved us into decimals. So I think I'm going to follow their example. But remember, in this case, I'm doing negative 5 divided by 1 times 16 over 20. I can cancel these out because I can divide both the 20 and the 5 by 5, and I end up with a 1 on the top and a 1 on the bottom. Oops, sorry, a 4 on the bottom. So I divided them each, and I end up with 16 divided by 4. I made a mistake. All right, sorry, made a mistake. I put 20 instead of 25. I knew that didn't make sense. 20, ugh, it's late, I'm sorry. 16 over 25, and then again 32 over 5 minus 3. There we go. So I can still cancel these out. You're a 5, you're a 1. I end up with negative 16 over 5 plus 32 over 5 plus 3. You know I like my fractions, but the book has jumped us into decimals at this point, so we're going to follow them. Negative 3.2 plus 6.4 minus 3, which equals 0.2. So we end up with a vertex of 0.8, 0.2. So this is pretty tight because we also know that our x's are 1 3/5, so 1 and 0.6. And don't put brackets around those because that means it's a point. It's not a point. There's just two of them there. So let's spread this out a little bit. Let's make every 4 points a 1. So year 1, year 2, year 1, year -1, or -2. So drawing this in, we need to put our x's on. So we've got an x-intercept at 1. We've got an intercept at at 0.6 or 3/5. So that's, if this is 1/2, 0.5, then it's a little bit more than that. So we're pretty darn close together. Then we've got our vertex is 0.8, 0.2. So it's directly in the middle of those two right here, about there-ish. And then it's only 0.2 up. So if we said this is 0.5, this is 0.25, doing all my fractions, it's only going to be right there. So we've got this very small sort of guy. Now remember that we need to label these. People have been forgetting their labels. So we need to label our points, 0.60, and our vertex, 0.8, 0.2. So that is, so then go back to the question, find the x-intercepts, the vertex, and the equation of the x symmetry, the equation of the axis of symmetry of the quadratic relations x or y equals -5x squared plus 8x minus 3, sketch the parabola. So I found the vertex, yes. I found the x-intercepts, yes. I found the axis of symmetry, haven't put that on yet. So let's draw that in. X equals 0.8. I forgot to label that. Good thing I went back to my question. Now, I know that I've got a negative parabola. Yes, check. I know that my y-intercept is -3. Yep, so this is probably going to be facing down for quite a while before it crosses. That makes sense. So my graph makes sense. I've done all my pieces and my graph makes sense. Solution from the textbook, if you want to pause and have a neater version. And our neater graph. All right, that is all we're going to do for this video. You can now complete questions 1, 2, 3 from the main homework. And 4, we can start on that too, and complete the practice questions that will be attached to this on Google Classroom. And that should be great for today.